about which I will be talking about later. Another design. So that was simple to see. To take cross section, there are only triangular channels. When you cut triangular channels, longitudinal channels on a substrate and cover it with another piece, you get the array of heat pipes. It's simple looking, but it's not easy to fabricate. Probably Kiran will tell me what is the difficulty in fabricating on silicon. Can I cut any direction on silicon? The problem is that if I say that I will cut 60 angles, 60, 60, 60, equilateral triangle on a silicon, is it possible? No. I have to go for 56.5 degrees or something. I have to go to the natural directions. If I want to use some process like chemical etching or something on the silicon. But if I want to microfabricate, I can do, but then triangle will not be a triangle. Okay, the size is so small. If I put it under a microscope, I'll see that it's not a triangle. I won't be able to get that. So because of fabrication bursts, I do not actually get the required effect, and then I don't have the corners proper, and heat pipe will not function. So these are all difficulties associated with fabricating those simple looking channels on a silicon wafer. So we have been thinking about what is another method in order to overcome this. Right at that time when I was working with Professor Peters and others were also working on this. So a simple thing occurred. This was his idea. Why don't we stretch a number of wires on a plate and put another plate over it? So what's going to happen? I'm going to get things like this. A number of wires are stretched on a plate and I put another plate over this. I have things like this. So what's in between two of these wires? Two of these wires in between, I have some region like this. And this is a heat pipe. These are what the corners that I want. These curvilinear squares that are happening inside can provide me meeting in these corners. So simple. So instead of cutting all these triangular channels over that, I just take two silicon wafers, sandwich these wires in between, and then put them together, stick them together by anodic bonding or some epoxy or something like, depending on how good you want to have it. And you could expect a structure like this, and these are called the wire sandwiched heat pipes. At those times we were calling them wire bonded heat pipes because we were putting it in bonding it using anodic bonding. Then I renamed it as wire sandwiched heat pipes later when we started working more on this particular thing. And these are designs which have been fairly good, and then on which industry has got a lot of interest for various applications. Application could be electronics cooling on silicon wafers, as I was telling. It could be even biomedical applications. We even worked on certain systems where we had this micro heat pipe arrays used for implants for brain cooling problems, epilepsy control, localized cooling of the brain. So we were thinking of fabricating on certain, I'll talk about those polymer films, where these are fabricated and then put inside, so that as Dr. Carpenter was telling, so you have a heat pipe like this, I have a pointed load on this one, this side, a hot spot, it's spread over the other side. This is exactly what I want when I implant. So I will attach it to a hot spot and keep it inside the locations where a hot spot can occur. And this is a passive device, it does not do anything. It's made of a biocompatible material, and the moment a hot spot occurs here because of epilepsy, this spread over the whole thing. So I don't have any more hot spots there. So this was the kind of idea, and then some tests have been done on animals. It has not gone to human beings yet. So this is under such heat pipe designs. Anyway, I was just telling about various applications of wire bonded heat pipes. It need not be electronics, maybe so many other applications. So basic idea is sandwiching these wires in between, and this is a particular case that we worked on, and then with theoretical analysis also.
Is it going to help you attach the wire to the solid material?
Which way? So basically it is possible to attach anything together if you use the process called anodic bonding. Anodic bonding is like keeping it together and then applying a high frequency, high voltage. So this will fuse the materials together. That is the best method. In my laboratory I have tried various things, including having a very thin layer of epoxy put over these wires, but it has to be done very carefully because it's not